Okay. All right, so we're back. All right. So now what we will do today is we will discuss the relational model. Okay. So all these slides, by the way, are available under the class materials folder. Yeah, so you can look at these slides in advance there. I went ahead and put all the slides for the semester up there, uploaded them there so that you can have access to them. There may be some minor tweaks and changes that we make along the way, so make sure that you keep up to date with them. But just for the purposes of you guys being able to have advanced, being able to look in advance at them and be able to see them, I wanted to make sure that you had access to all that. All right, so let's go ahead and get going. So what we're basically going to do is this will be the relational model discussion will be kind of, again, a broad overview of the topics covered in relational database management systems. Okay, so we'll talk about some terminology. We'll talk about how tables are used. There's a couple of slides about the mathematical aspects of the relations and in the relational model. I'm just going to kind of breeze through those because if you really love the high mathematical terminology and stuff like that, then it'll interest you. But most of I'm assuming most of the students in here probably aren't going to be super interested in that. You'll understand what a CK, PK, and FK is at the end of this, or at least you'll understand what they are and how to identify them. We'll talk about entity and referential integrity and a little bit about the purposes and advantages of views. Okay, now a relation, not a relationship, we'll get into that later, but a relation is a table with columns and rows. So if we think about it as it can be similar to an Excel spreadsheet. There are some big differences though, because in an Excel spreadsheet, there aren't as many rules that we will have to follow when we fill up a table. Okay, the attribute would be considered the column of a relationship, so it's what the data that it contains. So each row in a relation is an individual data, represents an individual thing, like an individual. If we go back to our class, an object terminology, a row is like an object. Okay. A column is like an attribute within that object. Okay. We can have domains specified, which means that we can have certain allowable values for one or more attributes. And there are ways that different DBMS options will allow us to set domains. So for example, on your identity information, there may be a birth date option. Well, we might say, well, the domain would be any date before today, or today or sooner, right? So if you are a person, if you're a student at the university, or you're a person in the Turkish system, or whatever, then your birth date will be some date prior to today. All right, so we can't say you are a person, you have a kimlik in Turkey and say your birth date is in 2024. Right, that's not possible. All right, and so the domain would be the set of allowable values. It could also include the type of value. So a birthday would be a date, right? Your name might be a string, or what we'll call a varchar. We'll talk about that data type later. Okay, so those are some things that we can say the domain is. It includes the type, as well as we can restrict what values are valid. Okay, a tuple is a way to say it's a row. I will call it a row most often, or I think a record is another thing. We'll talk about that, about the different terminology here. The degree is the number of attributes. Cardinality is how many rows that a table or a relation has. Okay, and a relational database is just a group of the tables of the relations, and each of those relations has a distinct name. So we can't have two relations with the same name. So again, the relation is going to be very similar to a class. And so just like we couldn't have multiple classes with the same name in Java, we cannot have two or more tables with the same name in a relational database. Okay. So here we might have an example of a relation, maybe called the branch relation. So branch is a location where people work. Staff will be people who work at that branch. So a branch might have such attributes as what's the branch number, what's its address, its street address, its city, its postal code, right? So the degree is how many columns are there, how many attributes are there. The cardinality is how many rows do they have. Okay, and we'll talk about these terms, primary key, foreign key, in just a moment. But the staff, as we can see, is another relation, has different columns, right? Because different attributes, because staff is different from branch, right? There's different information we're going to store related to our staff people. Okay. Some domain examples here, right? Might say it's a character of size 4, so it's a string of size 4. Right? The set of all street names in Britain, so clearly this is a British system. We can tell it how many characters these things can have, right? So it's a little bit different from a Java string, right? The gender of a person, male or female, the possible staff birth dates, right? It could range, what is that? 1st of January 2020? 1920. 1920 probably. All right, so we're saying there's a limit to how old the person can be. I would also say that we could say we should limit this to a certain date to how young someone could be. So for example, we might say if the birth date was 1st of January 2020, chances are we don't have a 3-year-old working for us, right? So we might put some kind of limit on how recent that date can be. Okay. We can also have staff salaries, give it a range of a certain value. Euro, pounds, I don't know. That is one thing that that I want to point out, is that our database is going to probably, for a thing like a salary, it'll be a numeric field. It won't necessarily tell us what the currency is. We may keep the currency as another column, or we might say all the currency in our database, because especially if this system is only for Britain, then we would maybe have the currency be defined by the system. It could be pounds or it could be euro. Right, and so if we were to have the same system for Turkey, we might say, you know what, let's not waste a column or any data on the currency. Let's just assume that we maybe make the system such that everybody's paid in tele, right? And so that's just set. And so then we don't have to use a column to store the currency value. Okay. All right. So this is one slide I do want to kind of focus on a little bit, just briefly, because I want to make sure that you know these different terminologies and alternative terminologies for different things that we'll talk about this semester. Okay, because the baby is an influencer. Nice. Okay. No, not for our stuff. These are what is it? MLOCs, right? This is like an MLOC system, so babies can't be MLOCs, I guess. All right, exceptions. Yeah, it'll just reject. We'll talk about that. Okay, if I'm understanding your question correctly, we'll talk about that, about how different attempts at adding or manipulating data in a database can, if there's something wrong with it, what happens. We'll talk about that. Okay, back to this. A relation will also be called a table. Could also be called a file. So it's based on the old file-based system. Is why that third alternative is there. I will probably use table most often and relation less of that. I will probably rarely use the word file for this, but I do want you to know that a relation and a table are the same thing. Okay. As far as the second type, a row, like a row in a table, it could also be called a tuple. It could also be called a record. Almost exclusively, I'll use row. On an occasion, I might call it a record. Tuple, probably very rarely. As far as the last, so the column, right, of a table, attribute, column, field. I can't tell you which one of those I'm going to use most often because that I probably use them all equally frequently. But you do need to know that an attribute is also called a column, is also called a field. Okay. All right. Let's see. Wait, we have a question here. What I would say is it depends on the system. If a country changes their money to euro, you could do an update. We'll talk about how to update using SQL. That'll come up next week. It kind of just depends. Okay? Like for example, last year I ran the Runtalia. This year I signed up for it again, and the fee is, if you have the website in Turkish, the fee is 350 TL, I think. If you have the website in English, the fee is 40 euro. So obviously they're not doing a based on the current exchange rate, right? So obviously those two values are stored in a separate place in the database as separate values. Yeah, so that's an interesting question, but I would say it depends on what they're doing. Are they wanting to offer a system that can use both currencies, in which case you might need separate fields, separate columns for those things, or are they wanting to convert it over to the new currency, in which case you might change all of the values in the different rows to that. Okay, so as you guys are used to me saying, it depends. Let's see. So make sure you know the things there, the different alternative terms for those things. All right. This is that mathematical definition where it kind of talks about Cartesian products and understanding how tuples work in terms of Cartesian products. Again, I don't want to spend a lot of time on this because this is one of those things that if you really want to get down into like an advanced database design system, if you want to become a designer of databases and database technologies, this can become important. If you really just love maths in our British English and Cartesian products and all that, these might be some slides you would like to see, but for us, this is going to not be very important. So I'm just going to kind of skip through that a little bit. Okay. But some other terminology. A relation schema is it's a way we define the relation. So a schema is the definition of, and so we have a set of attribute and domains that we can say that is how we define what the relation is, the table is. A relational database schema tells us all of the relation schemas, so all the tables that we have in our database, and each of them has a distinct name. It doesn't say this in the bullet point here, but I will say that a part of a relational database schema would also include the relationships that are defined between the different relations. For example, in a school system like ours, you might have one table that represents a student, You might have one table that represents courses. There's a relationship between those, right? There's a many-to-many relationship between students and courses, where one student can take many courses, one course can have many students, right? And so there is a relationship there. I'm trying to think of what a one-to-many. A course in a particular semester might have a one-to-many relationship with teacher, though, right? So a particular course or a particular section of a course in a particular semester would have a one-to-many relationship with teacher. There's one teacher for that section of that course, and so that might be an example of a one-to-many relationship. And then when we talk about it later, when we start talking about ER modeling, we'll also talk about one-to-one relationships, because sometimes we might have that as well. And so we'll talk about that, about where that might become important. Okay. Some properties of relations. All relations will have a name. We'll have to have some way to identify what the relation is. Just like with class names, we do want them to be descriptive of what data they hold. Okay. Each cell of a relation contains one value, so we can't have more than one value. We'll talk about how to make all this happen. An attribute has a distinct name. Now, an attribute in one relation can have the same name as an attribute in a different relation. So, for example, if we had a teacher table and a student table, both of them can have a name column. Both of them can have a surname column or a soyada, right? Both of them can have a birth date. Both of them can have an email address and so forth, right? So just because an attribute name exists in one relation doesn't mean it can't exist in another relation. Same thing with, again, with classes from Java. Fields in one class can have the same name as a field in another class. Okay. Values from an attribute are all the same domain. So if we set a domain for a column, we're saying what values can we put in there. If we try to put a value that's outside of that domain, that's not allowed, then we won't be able to enter that information into that cell, into that that row. And what a database management system would do in that situation, we'll talk about. Okay, because we'll see. There are no duplicate rows, so in a database system, we'll talk about how to make sure that no duplicates exist. The order of attributes has no significance, so we can take the columns and reorder them however we want. No difference. Order of tuples, theoretically, in theory, has no significance either. So the order of the rows has no significance. So if one student appears above another student in the table, in the base view of that table, it doesn't mean that that student is higher than another student or something like that. When we go to view the data using a SQL query, it is possible to use an order by so that we can sort them based upon something that we define, but it doesn't change the order of them in the base table. Okay, it's how we view them. Okay. One thing that we will talk about a lot is we'll talk about keys. All right, so there are some different keys that we'll need to talk about. One of them is a super key. So a super key is a single attribute or set of attributes that uniquely identifies a row. What that means is that we might not need all of the attributes in a table to be able to tell what uniquely identifies a row. Okay. So let's look at an example. Let's look at you as a student. Okay. If I needed to identify you as a student, would I need all of the information about you? Would I need, so let's say if I had your first name, would that uniquely identify you? No, right? What if I had your first name and your surname? Does that uniquely identify you? Probably not even that. Okay, well, let's add some more information. What about name, surname, and birth date? Maybe it could, but yeah, even that's not a guarantee, is it? I would need to get a lot of information in order to uniquely identify you, right? So do I need to, in order to uniquely identify anyone? There you go. I can, thank you. Right, so if a significantly small set of attributes are, if we don't have them to be able to uniquely identify you, sometimes in systems we will give you some type of unique identifier, right? And so you guys are identifying here your student number for the university is your unique identifier, right? Do you have a unique identifier in the Turkish system? Yeah, your TJ number, right? Your kimlik number, as we might say, right? So why didn't the university just use your TJ number? I ask the people who designed OBS, I guess. I don't know. So that doesn't mean that always we will give some column, some value to uniquely identify a thing. Right. Sometimes existing data will already include within it some information that we can use, some set of attributes that we can use as a unique identifier. Right. And so this is where this concept of a candidate key comes in. So if I were to have your student ID, your first name and your surname, and I were to include those three attributes together, does that uniquely identify you? If I had your student ID, your name and your surname, does that uniquely identify you? Yes, right. Now, do I need all three of those to uniquely identify you for the university system? No, right? So, but a candidate key is your ID, right? A candidate key is some set of attributes that uniquely identifies a row, but I don't need a subset, right? No subset could identify the row on its own. So if I had your name, surname, and student ID, I could uniquely identify you, but there is a subset there. So name, surname, and student ID is not a candidate key. Okay, so the reason why we call this a candidate key is similar to an election. Like you guys have the Turkish government has an election coming up soon, right? What's a candidate? A candidate is someone who wants to get chosen for a special role, for a special office, right? So what's the candidate key? What special role, what special office is it trying to get? It's trying to get, I need to change the focus here to this. It's trying to get the office of primary key. So a primary key is simply a candidate key that we selected to identify tuples, to identify rows within a table. Okay, so a primary key, if we can't find one within the, data that already exists, within the attributes that already exist, then we often key. So that's what happened with your student ID. That's what happened with your what is it called? With your TJ number. For those of you who have bank accounts, you have an account number, an IBAN, right? Do you say IBAN? 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 I don't know how to pronounce that in Turkish. But you have an identifier for your account, a special identifier that was given to your account to uniquely identify it, right? So alternate keys would be any candidate key that isn't used to be the primary key, because we can only have one primary key, where there's only one thing that we're going to say that is going to be what we use to uniquely identify row in this table. Okay, and then so we've talked about CK, PK, foreign key or FK. We talked listed that at the beginning on the outline. That is going to be an attribute or set of attributes that matches the primary key usually, but it could be a candidate key of some other or possibly same relation. So, for example, if I wanted to say what students are in this class, what students are in this course right now, right? I wouldn't want in the course table, I wouldn't want to have to store your student number and your name and your surname and your birth date and your email address, but I wouldn't want to store all that within the course table, because that information, all that other information, all your name, your surname, is not really important to the course, right? What do I need to know in order to say this student is in this course? I just need to connect your primary key to this course, right? And then that puts you in it. Right? That's the only information I need from the student table, is what is that student's student ID. Okay, so that's important for us to know, because as we start designing these databases to be designed well, is we need to know that there's some information we don't want to duplicate if we don't have to. Okay, so a foreign key is some attribute that represents the primary key or candidate key of another table. And there can be what's called a recursive relationship, where the foreign key actually points back to its own self, to its own table. We might say if an employee of a company has a supervisor, right? We might say, well, what's the employee ID of the supervisor, to say that person supervises this other person, right? Something like that. Okay. Some integrity constraints, right? Null would be not 0 for numeric values, not empty string for string values, not false for Boolean values, right? Null it represents something that's not known, right, or does not really apply for that row. So for example, let's say I want to store information related to people in the Turkish government system, right? Well, things that I need to have for every person might be a TC kimlik number, right? Everyone needs a first name, right? Everyone needs a surname. Does everyone need a phone number? Does everyone have a phone number? Right, yeah, my children might not have a phone number, right? Or somebody might not have a phone at all, right? Or an email address. Maybe not everyone has an email address. So that could be, we would leave that blank, if you will, but it just means that we don't know. Right? It's not that null represents the lack of existence. It doesn't mean that null means the thing doesn't exist. It just means we don't know. Okay. And that's going to be very important for how database handles null values. Okay. And we'll talk about that more in depth when we get into SQL next week. But it just represents the absence of a value. It's not the same as 0 or spaces, because those are actual values. Okay. Null just means we don't know. Okay, and there's some rules involving null, right, that we'll talk about when the time comes. Okay, so for example, one of the things we'll talk about is that no attribute of a primary key, so if a primary key contains multiple columns, no attribute in there can be null, right? So we cannot have a primary key that has a null value in it. Okay. Referential integrity. If a foreign key exists in a table, the foreign key must match the candidate key or the primary key of some other the other relation, or the foreign key value must be null. So in other words, what that means is, let's say I would say for this course, if I had a student number column that's saying what students are in this course, if I put a student number that doesn't exist in the student table, that doesn't work. Referential integrity is not maintained. Why? Because the student number that it references, that student doesn't exist. So it would be like saying a student who doesn't exist is in this course, right? Not possible, right? And so because that doesn't make sense, if we enforce, and again, it must be enforced in order for it to work, but if we enforce referential integrity, then it means that either we could say there are no students in the course. That's a possibility. We could leave it blank. Right? Or we could say any student that we put in the course must exist in the student table. Right? We can only put students in the course that actually exist. All right, so there are some other general constraints that we might put, like domain constraints and stuff like that. Well, and again, we'll talk about all that later when the time comes. Okay. Now, there is a difference between base relations and views. Again, we're doing a overview right now that we will get into more details in later lectures when the time comes. Right, a base relation, we may also call it a table. Right. Those things are actually stored. That data is actually stored in the database. A view, on the other hand, is a result based upon the existing base relations. Okay, so again, as I've said before, my view of the OBS system looks different from your view of the OBS system. There's a lot of things that you need to see that I don't need to see. There are things that I need to see that you don't need to see. And it's not just about that I'm a teacher and you're a student. It's even, say, for example, there are things that Nelly Hoja gets to see in the OBS system that I don't get to see. All right, that makes sense. There's also things that the rector gets to see in the OBS system that I don't need to see. And we can do that through views. Right, so those are all things that views we can use based on what they need to see or what's helpful for them to accomplish their task as employees that use the system. Again, it's a virtual. It acts like a virtual relation. It does not actually exist. It's basically gives us the data at the time of request. Okay. They can simplify complex operations. We can basically, if let's say, for example, the value stored for salary is a yearly salary, how much does the person make in a year? But we want to know what their monthly salary is as part of a view. For whatever reason, we can do that as part of a calculation in a view. Okay, so we don't have to change the data in the column. We don't have to change the data in the database to make that happen. We can look at it at the time that we are wanting it. There are some views that are updatable, right? But again, because the view itself, the view itself is not the data itself. Those are stored in the underlying, the base relations, the tables, right? If we have what we call an updatable view, then when we update the view, we are not actually updating the view itself. We're updating the data in the table underneath. Okay, there are some restrictions, and we'll talk about that when we start talking about how to define views. Let's see. So, is there anything else particularly? Right. So, like here, there are some views that will not be updatable. Okay, there are some views that will be updatable theoretically, and there will be some views that are partially updatable. So we'll talk about how to know the difference and what some of the rules are about those when that time comes. Okay, all right. So again, this is week 1. So let's see. So I need to let me save this before I forget. Where are you? Oh, I need a new folder. Okay, so there we go. So that's saved over there. Let's see here. Are there any questions? So again, this is week 1, so I don't want to overload you guys too much. Well, there'll be plenty of time for that starting next week. But is there any questions? Because if not, we can end here. So I know MySQL does not make that requirement. Some DBMSs do require that you define a primary key for every table. MySQL does not have that requirement. Basically, if you don't define a primary key for a table, what the system will usually do is just say, okay, all the columns together make up a primary key. So what you would end up with is if you had a 10, like so for example, I can share this again to show here. So for example, if I made this table, this movie table here, I would end up with a 15 column primary key, okay, which could be quite difficult to reference it in other tables that reference that movie. Yeah, it's a good question. So yeah, so we'll talk about how to determine what might be a primary key in here, or if we need to create a new column to represent that primary key. Okay. Good question. Anyone else? All right. Well, thank you guys for attending, and thanks for, I love when I see a lot of comments in the chat, meaning that you guys are involved and hopefully paying attention. So I will see you next week. Have a good weekend, and yeah, thank you guys for attending, and let's get through this online semester, and hopefully we can get back to something resembling normal next year. All right, have a good weekend.